Alright, time for another DraftScience video presentation. Talking to the very few people on Earth who seem to care, about what the truth is. Getting a right answer, having a right understanding of reality. Ugh, just depressing how few humans are interested. So there are people who are smart and educated, but they're just educated into sort of a bandwagon of belief, and they just go with it. Whatever crap they've been told, they just keep gurgitating, and it's just it's not really intelligent. It's just memorize and recite, like a piece of poetry or something. Anyway, no scrutiny, oh, let's think about it. Let's talk about it. Let's do some of those things. So they're really obnoxious to any kind of conversation about how they might have something wrong, that their little picture is just pictures. It's just, anybody can Photoshop anything. It's taking a real picture that's the tricky part. And so anyway, there should be some kind of channel where each one of these little subjects is discussed. What is an atom? What is a photon? What are the elemental particles? What's a force? What's energy? But no, there isn't any place on YouTube to do that. And again, as you can see on the science forums, anytime the subjects are brought up, there just is no tolerance for any kind of dissidency from the jargon and the BS of the standardly accepted, the pop culture definitions of reality. So anyway, it's a very discouraging environment. It's just you can just see that you having a I thought the obligation was to have the reasonable argument, and it really isn't. It's just people just don't care. Reasonable arguments just no, that's not thought provoking. Counter descriptions. So I can keep asking questions like, come on, it doesn't bother you that a science that's supposed to make sure it's got the right answer and it's done all this, everything it can to verify its information, and it can't repeat things like the Eddington experiment. Experiment's fundamental to their physics. You can't even talk about some other model of an atom besides this idiotic Bohr bullshit model. It doesn't work. It isn't rational. Atoms stick to each other because an electron is doing this shit. Come on. Why do you believe this crap? But anyway, so I was just looking at physics channels, Physics Explained, and it's just, this isn't an explanation. This is just propaganda. We'll tell you what the truth is, and every bit of it is just so full of crap. So I'll just read this little bit because it's just such a pile of crap. This video looks at the history of the ideas behind the concept of wave-particle duality. There's a concept of this duality beyond the fact that, we're just going to use it because we can't fix it. Come on, this isn't a concept like there's a real wave-particle duality. Even Feynman will say it's, this is ridiculous. There's no duality. There's a reality, and you haven't figured it out, and that's why you're playing this duality game, is because you can't figure out why sometimes it looks this way and sometimes it looks that way. Well, it's not doing it because it's actually duality. Anyway, with a particular focus on the work of Louis de Broglie, which is this silly idea that Volkswagens have a frequency. That you, walking down the sidewalk, have a frequency. And there's no evidence that you have anything called a frequency. There's no evidence you have a wavelength. There's no evidence of any of that crap. Anyway, and the matter-wave hypothesis, right? So So 1 minute they say there's wave-particle duality, it's a concept, that's what we believe in, yet we're pretty much sure that even matter is waving. Everything is a wave. In what? I don't care. We don't need to answer that question. We don't have to answer what's waving. No. That's for some other planet to do. It's not the job of the Earthlings who believe in their matter wave hypothesis to explain what the fuck is waving. It's just so bad. After discussing the groundbreaking work of Thomas Young. So here we go again. The groundbreaking work. So Newton had already done this experiment. There, I put light through a little hole, and it seems like it spreads. And then he did I stuck a hair in front of the light, and it seems like it spreads. And it's so obvious that, well, what does this have in common with this? Two surfaces. That's what it has in common. And why does the light seems to spread more when the surfaces get closer together and the light doesn't have much of a choice? How come? And if I make the hair thinner and thinner, the light spreads more and more. So it seems like it doesn't really matter about the confinement. It just matters about how far apart the surfaces are. Anyway, I mean, it's so bad, that they bring up Thomas Young because he didn't do anything groundbreaking. Newton had already done these experiments. Newton had already defined Newton's rings, as a phenomenon. There was nothing new here. So this is just a gimmick experiment. And on top of it just being a gimmick, I added 2 slits instead of having 2 surfaces. So now I have 4 surfaces. That's all. A completely inevitable perception. And the key feature is Thomas Young's groundbreaking work was so bad, the image is so bad of the phenomenon of diffraction that it didn't even reveal that there's actually 2 patterns. That the double slit pattern is, you have to say, the most intriguing aspect is the fact that there's a bars of on-off, and those bars are in a separate envelope of on and off. They're in, say, 10 bars here, and then no bars, and then 6 bars, and then 4 bars, and so there's 2 patterns. Young didn't know that. And Young's math didn't work. So if you actually, started doing the experiment better and better with more and more precise instruments, you find out 2-wave theory doesn't get you the right answers. You have to use a 4-source theory, the surfaces. So now we're back to the Einstein thing and hidden variable theories versus bullshit. It's random God did it. It's that simple, right? You're just saying, is there a variable causing the effect? Clearly, what's the variable in the experiments? The slits or holes or whatever. What's the variable? The surface. Duh. Shit. This is so bad. It's, you can't even... I can't describe just how amazed I am that smart people are this profoundly dishonest and stupid not to acknowledge these are the facts. The facts suck. There is no good reason to say the groundbreaking work of Thomas Young, because there was nothing groundbreaking about it. It was just propaganda in support of a ether theory. It's not good physics. It wasn't good science. Just like all the French clay experiments. Or German. Anyway, and the concept of wave interference. So, wave interference that doesn't work. If you do the double slit and you talk about 2 waves, you won't get right answers. You won't describe reality. You'll get the wrong answer. A brief discussion. Yeah, see, there is no discussion. They just, Anyway, is given to Einstein's explanation of the photoelectric effect. Well, Einstein really revealed that, well, he didn't, frankly, he didn't reveal the real truth, which is we detect photons with a clump detector. We can't detect photons with something other than a detector that needs it to be a clump. We don't have some other way to look at photons except viewing it through a clump detector. So they look clumpy because the only way we see them is with a clump detector. Anyway, I mean, it's just will I get any rational reply to any of these points? Will anybody please make a rational reply and explain how Young's experiments, Young's drawing of two waves, gets right answers? Show me the evidence of that. I mean, it's just a fact that the math had to be refined and fixed, and nobody does the real math because it's not easy and fun. But there is a real math that actually gets real right answers. And it's not Young's geometry. Anyway, a brief discussion is given. Okay, this provides a launch point for a discussion. So there's no discussion. There's just propaganda of de Broglie's matter wave hypothesis. La 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 la. So they turned frequency into energy. So instead of understanding that, well, of course, if I shoot bullets really fast, more bullets are going to be in the space than if I shoot them really slow, then there's fewer bullets. So obviously there's going to be more energy associated with higher frequencies. If something happens more often, if somebody punches you in the face more times per second, it's going to seem like you're getting beat up really fast, and there's a lot of getting beat up. Duh. Does it mean that there's more energy fundamental in the frequency? No. It's just a consequence of a higher frequency. And so then they decide that everything that hits something else and seems to have a lot of momentum has it because it has a high frequency, that somehow it hit more than once. That the car crash was, a frequency crash. Oh, no. None of that. There's no reason to believe any of that mush. Alright, this provides a launch point for a discussion of hypothesis and includes a detailed analysis. Ooh, interesting. Of Bohr's model of the atom. So there's no detailed analysis because Bohr's model wasn't detailed. So they're talking about how we've changed Bohr's model. We still call it Bohr's model, but it's not really Bohr's model. I mean, his model was silly. He was, in fact, basically a religious kook. Okay, and, and told Einstein, quit telling God what to do. That kind of crap. Didn't believe the universe was actually a material thing. He didn't believe in physics, for fuck's sake. He didn't believe it's a physical universe. He believed in a mushy little spiritual Leibnizian solitons and monads. I never heard him say that. I mean, I don't have any quotes of Bohr saying soliton and monad. But that's where his head was. Up some kind of gooey religious butt. Ugh. Alright, anyway. It's a crude drawing of, yes, we could all draw that conclusion. We're saying, well, what's an atom? Okay, we can shoot shit through it, so it's obviously got some invisible parts. So we figure out, it seems to have these charged elements in it, and they seem to be very, very local, very small compared to the actual size of the atom. So the atom is a composite thing. And so how do we keep these charges from crashing into each other? Well, we just give them motion. But the truth is that we think of them as magnetic monopoles. We can make a model of the atom that's sort of proven, right? So now with all of this, the super cooled, what do you call that? Well, anyway, where you get stuff to float, right? All of that kind of points out what the real model of the atom could have been, which is just to make electrons and protons north and south poles, and then you could understand that they could be in an arrangement where they don't move. You know, I can make a magnet float on top of another magnet. You know, put a stick, you know, and then I put the magnets on the stick. I can make them float there forever in one position, you know, because they're bound by different charges and a little tiny bit of structure. And so you can understand the magnetic model works. And now when atoms share an electron, they can literally share it. The electron is sitting here in space, and the protons are here, and then there's another proton, and it's missing an electron here, and it can just fit, and everything works out just fine. So the Bohr model doesn't really make any sense, but you have to think about, well, where did the electron get this velocity from, and how come it's just the right velocity? And, you know, why doesn't, you know, there's implications. Just to understand that if you give electrons all of this spinning motion, there's implications that don't work. And they know it. I mean, they'll concede that the Bohr model doesn't work because, you know, the electron is supposed to crash into the proton, and it doesn't for some sort of magical reason. Anyway, as well as the interpretation of the de Broglie wave function, so more de Broglie, using the famous double slit experiment. The famous experiment for which you inevitably, I'm quite sure this video will describe completely incorrectly. We'll use geometry that in fact doesn't get correct answers. It doesn't predict the actual physical reality. It won't explain the two patterns at all.
The story of wave-particle duality begins with the story of light. Light is the most ubiquitous of...
Now, light is a force. Okay, that's what it does. It imposes action on things, and like all the other forces, it's a force, and it moves at the speed of force.
Physical phenomena. And yet, for the majority of human history, it has evaded explanation.
So it's evaded an explanation that accounts for all the phenomenon. So there are different things light does, and different effects, and they haven't come up with a model that fits all of those effects. And then they turned it into this electromagnetic thing when it doesn't have any electro or magnetic. You can't bend it with a magnet, okay, and you certainly can't bend it with an electro, whatever that would be.
Light makes the universe visible to human beings.
And why? Because it's a force, and it bounces off of stuff, or it gets absorbed by stuff. So we don't see the light that got absorbed. We see, oh, I see green. Why? Well, because the red got absorbed. That's why. It doesn't reflect off the object. It goes into the object and heats the object, and you can just follow the momentum. And we can understand all of that. We do understand all of that. I mean, there's no real argument about thermal aspects of the atmosphere and what happens and global warming and all these things are based on understanding, you know, the greenhouse effect. I shouldn't even say that just because the greenhouse effect is sort of not entirely accurate the way it's described. So that's another one they sort of have a model, but it's a little bit off.
Revealing the rich tapestry of colour.
La 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 la, baby dog. Oh, the rich tapestry of blah 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 blah. Clearly, all the light, okay, whatever we know about light is that it's force with a frequency. It actually has a wavelength, okay? Unlike electrons and Volkswagens and people walking down the sidewalk and dog poop falling out of a dog's butt, all of those things don't have a frequency, okay? They just have a velocity. They don't have any wavelength.
And textures that helps us to distinguish objects and navigate.
La 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 la. Help. This isn't about what helps us. It's about how the physical universe functions. So let's not have all of this glorifying rhetoric and all this gooey human-friendly bullshit. You're supposed to be talking to people who are smart, and apparently they're really not that smart because they fall for this gooey bullshit. They don't find the gooey bullshit obnoxious and irritating, which they should.
Through the world. Light has been worshipped by countless...
Oh, shit. That's the negative side of the story, okay? So that's not the... Oh, yeah, that's part of the physics history. The science history is the worshipping part. No, that's the part that ruins the science, is the worshipping part. That's where it all goes bad.
cultures. It lies at the heart of myths and poems and stories of our creation. And it has been studied by philosophers and...
Okay, so it's whatever. It has been studied, and obviously, like a lot of other things, like Sasquatch science, okay, some of the science has sucked. Okay, it's been just fundamentally inaccurate and wrong. And clearly, the Young experiment was one of those missteps, where nothing remarkable was done. Newton's had already discovered the phenomenon, and they just poorly interpreted it again.
Scientists through countless generations. But what exactly is light? Is it a wave, or is it a particle?
It's a composite object made of particles. Everything's made out of little bits. It's either a force bit or a matter bit. That's all there are in the universe. The force bits are moving the speed of light. All the forces move the speed of light, and they all convey momentum. And then there's these other objects, a little bigger, electrons and protons. And we know they're charged, and what makes them charged is how they react to the force. Okay, so obviously the negatively charged object, I shoot a force at it and it runs away. Positively charged object, I shoot the same force at it and it runs towards. So obviously there's an interaction between the force bits and the matter bits, and that's what's holding the universe together. That's all that's happening. Force bits go the speed of light. They impose some momentum on matter bits, and they go a little less than the speed of light when they're being pushed by matter. Or maybe a lot less.
Or is it something else entirely? To answer this question would require thousands of years of experiment.
So they think they answered it with a retarded nonsense. It's wave particle frequency stuffy thing. Quantum blah blah. It's a shit answer. They haven't answered it, so they've done thousands of years, and they've done it so badly. I mean, even like the Eddington experiment can be brought up again, because it's another light experiment done badly. You know, exaggerate the outcome, exaggerate the credibility, exaggerate the precision, and pretend they did something, you know, and just believe it. So they all believe that light is twice as bent by gravity when there isn't any evidence actually that it's ever bent by anything. It's a force, and there's no evidence that forces interact with forces. That's why the matter is sort of important. It's because the only time a force can act on another force is with the conduit, the catalyst of the matter. The matter bit does the math. Whatever's happening in the universe with the forces, the only way to know what's happening is to see what the matter's doing. Because the matter's the only thing that can add it up.
And theoretical inquiry, and would involve a selection of the most famous scientists of all time.
Right, and they're only famous because you say so, because you say they're famous, because you've made them famous, because you all talk like, oh, they did something miraculous. Again, the Thomas Young experiment is ugly, okay? We don't even have, like, it doesn't, we have drawings of it, I think, and that's about it, of what he saw. What he saw was crap. It wasn't even the double slit reveal. It didn't have the two patterns in it. I mean, and, you know, groundbreaking. No. Ground ruining, okay? Quicksand making. You fell into the quicksand. You decided, it's confirming it's a wave, because we all want to believe in that anyway. It's quicksand.
Time, weaving together ideas across generations, overthrowing long-held ideas and beliefs.
Whatever, you know. Ignoring alternative reasonable explanations because you're devoted, okay, to you know, endorsing your mommy's theory. Mommy thought so. My mommy thought so, so I'm going to defend that theory. Because mommy told me so.
Beliefs and forever changing the way that we view the universe.
Well, the way you view it, okay? It's sorry, I never fell for the religion stories. Okay, they're all stories. So you never convinced me with the Bohr model. You never convinced me that light's a wave, especially a wave going two different ways. Ugh, shit. No, I never fell for it. I wasn't, you know, I was somehow born smarter than you? No, I was born less gullible than you, apparently. That's all. That's all there was. That's all the difference, right? They didn't just tell me a story and I instantly believed. Especially stories that are incomprehensible. Again, I mean, even when you're told about heaven, you're saying, oh, where do I go to fuck the babes? I mean, there's no talk about heaven being any kind of world I'd want to live in, right? Do I still have to wear clothes in heaven? I mean, do I have to go to the bathroom in heaven? Oh, I don't want to bother then.
So what is light? To even pose this question represented a huge leap forward in our attempt to understand the universe.
I don't think you want to understand the universe. You just want to you want to believe in a bunch of fairies and bullshit. And the whole science is so ugly with pixies and gremlins and, you know, gingerbread houses. It's all made out of frickin' fables. This stuff isn't even close to being what science should look like.
To believe that light is some thing that can be investigated. But if
yes, it's easily a thing. Okay, no doubt about it. It's a thing. It's, you know, it's a happening. Okay, we can all figure that part out. And anything that's happening, well, it seems a good idea to investigate it. And the whole argument is, have you investigated it at all honestly? Or have you investigated it as a bunch of mobs? And it appears that you're just mobs of Christians and mobs of Muslims. You're just people with a frickin' perspective that you're imposing on the evidence. You're forcing the evidence to fit your will. You're not finding the truth. You're shitty detectives. You know, you're not like Columbo or something. You know, Columbo doesn't fall for the butler always does it. You know, you have to actually piece the evidence together, and, you know, you have to realize that the criminal might be trying to fool you. You know, that it might just be, oh, there's a coincidence, and coincidences are, oh, damn it, they're really tough. You know, it's they can really mess up your brain, so you have to be really careful to say something like, well, because water does this, and it looks like on, off, and this over here is doing on, off, you have to realize that, oh, wait a minute, on, off is the simplest pattern you can create in the universe. You can't make a simpler pattern. So of course that pattern might show up in a few different places, and I shouldn't be surprised that, oh, on, off, the simplest pattern in the universe, shows up in different places for different reasons. Shit.
light is a thing, then what kind of thing is it?
It's a bunch of little bits of momentum, okay, that has a polarization that's very, very large. You know, thousands of atoms, and the little bits hit a surface at a frequency. That is, one hits, and then the energy moves through the substance, and then another bit hits, and it gives it a little bit more energy, and then another bit hits after that and gives it a little more energy, and then another bit hits it and gives it a little more energy, and that's called making electricity. Because what will happen is you'll keep pushing an electron a little faster, and eventually the electron will be moving fast enough to be knocked out of the atom, and that's called charge. So you created a negative ion, an atom missing an electron, and what happened to the electron became a positive, an extra electron on the surface. which means now the surface of the object is now charged. And that means it's electric. Shit. That's the simple answer.
Some of the earliest documented theories of light came from India and ancient Greece.
Well, that certainly doesn't charm the hell out of me. So, who cares? Some of the ancient theories, you could say about all of the ancient theories that, well, they're all probably a little flawed. Because they didn't have enough information. They didn't have telescopes and shit. They didn't even have a lens yet.
Many of these theories sought to describe light as a ray, a straight line.
There you go. Yes, and it was really smart way to look at it. It's really smart way to look at it because that's exactly what you can see happening. The light reflects off the water and makes the tree lighter. You can see it happen. You can see it looks, there's so many things that give it away. Reflections especially, and glare and all that kind of stuff. And that's all stuff a common man can see in the world. The shadow. You can see the shadow. You can see the things that are telling you basically this seems to be little stuff like rain, and you can seem to block it, by absorbing it, or blocking it by reflecting it, and so it doesn't hit something else, and it looks like it's in little rays. Little rays makes a huge amount of sense, a gigantic amount of sense. It's a really good theory, and you said fuck it, so you could go sail on a wavy boat.
Moving from one point to another. Pythagoras, best known for his theorem of the right-angled triangle.
Really no point in going back that far, just because we have compiled so much evidence since Pythagoras that there's just really no point in saying what was his opinion. Because he didn't get to see any of the DNA evidence, he didn't see any of the stuff that really matters, and I don't think he would agree with his opinion, okay, if he lived another couple of thousand years. Yeah, he'd have a different opinion now if he was looking at the evidence. And I don't think his opinion would be your opinion.
Proposed that vision resulted from light rays emerging from a person's...
Right, now that was really dumb. So, that one you could figure out just because it's such a obvious, that I don't have to throw light at the sun for the sun to shine light on the earth, that kind of, that's just too silly.
Eye and striking an object. Epicurus argued the opposite. Objects...
There you go. And he was probably righter then, right? Yeah, that's smarter.
Produce light rays, which then travel to the eye. Other Greek philosophers, most notably Euclid and Ptolemy, used ray diagrams quite successfully to show how light bounces off smooth...
There you go. So it works. It's a good theory. We probably should stick with it. Let's take it all the way to the end and see how it holds up. And everything would have been just fine. But instead, for whatever dumb reason, smart people decided, let's just walk into the quicksand and die. For no good reason.
Surfaces or bends as it passes from one transparent medium to another. Centuries later, Lucretius, who, like Democritus before him...
This is, again, I'm just going to say, who cares, who cares, who cares, who cares? This is so artifactual. There's just no point. It's just, this is, this is like analyzing British war strategy, from 200 years ago or something. Yes, let's just have all your troops line up and be targets, so we'll put the poor people in the front so they get shot, so the people in the back can shoot the other guys. Let's distract the other soldiers to shoot these poor guys, the suckers, so we, in the back can shoot them.
Believed that matter consisted of indivisible atoms, thought that light was made of particles travelling in straight lines from...
Yes, I'm just saying the idea of straight lines really works, so that's a good idea. And the idea that momentum runs the universe, like the whole universe is being run with this energy shit, and it seems to recycle. It doesn't seem to go anywhere like it really dies. It doesn't really die, okay? It just moves as heat through the universe. And sometimes we can see the heat because it's at a frequency, and then sometimes we can't see the heat because it doesn't have a frequency. But we can fall in it like gravity. It's all heat. It's all just momentum. That answers all the questions. A simple model works. Evolution works. Particle theory works. Shit. Just so tedious.
In the sun. This provided a simple explanation for the formation of shadows. These were just regions in which the light particles couldn't reach, with the sharp edges of the shadows simply representing the boundary between where the particles could and couldn't land.
Right, and the fact is the shadows aren't that sharp. So that's what we can find out with our little microscopes and telescopes and our magnifying devices. We can see, oh wait a minute, it's not that sharp. But it's not way off either. It's not like way blurry. It's just a little tiny bit blurry. And why would that happen? Oh, because it seems like surfaces screw up light a little bit. So it causes some scatter. Some of the light scatters when it goes by the surface, and so some of it goes that way, some of it goes in. So it makes a blurry line. Simple answer. Makes perfectly good sense. Surfaces cause effects to the light. That's why the light's bent going through a transparent medium, is because the surface is fucking it up. Shit. That's the hidden variable. Not very hidden.
During the 10th century, the particle theory was developed in Egypt by the famous Middle Eastern mathematician Ibn al-Haytham.
Well, he wasn't that famous because that's the first time I've ever heard his name. But whatever. His fame didn't, he didn't get on the Wheaties box.
Published a book of optics in 1027, which was the first comprehensive treatment of the properties of light, including the physiological treatment of the eye and
physiological. Anyway, that's all. We obviously have light detectors, but what are they again? They're clump detectors. How does the light detector in our eye actually work? Oh, that's right. It has to cause electricity. Electricity has to go to our brain. Our optic nerve isn't carrying photons, technically. It's carrying electrons that are representing what the photons did to the surface in our eye.
The bending and focusing properties of lenses and mirrors. But perhaps the most significant development of the particle theory of light was that of Isaac Newton in the 18th century. Newton showed how reflection, refraction, and dispersion.
Yeah, he did slit experiments, surface experiments, and found that light is diffracted. That is, it's kind of scattered by a surface. Simple answer.
Could all be explained by the particle theory. According to Newton, light comprised a continuous stream of particles.
Now, the part that Newton didn't get right, is the part where it goes into a surface isn't diffracted. Okay, so he certainly did explain it with a particle theory, but the explanation was crap. So let's understand. It's just, it wasn't accurate. Because he didn't know what atoms were. So he didn't understand that, well, why would the light bend going into the surface? Well, of course, if you understand a magnetic model, you would understand that the electron was going to tend to move into the surface. So if you hit it at an angle, it's going to move straight into the surface. There's always going to be a tendency for the electron to have to change the direction of its motion. You can't hit an electron and oblige it to go straight when it's part of an atom. The atom will force the momentum to have a new vector because it's a magnetic matrix. So the light's going into a magnetic matrix, and then when it's leaving, it's doing the same thing. It's leaving a magnetic matrix. The electron can only move in certain directions because it's bound to the atom, and those directions are what's bending, okay, the movement of the matter. And the movement of the matter is what's creating the force change in the universe. Just like this hand moving is changing the force in the universe. Well, that's how electrons produce photons, is by moving the pieces of a photon. So an electron doesn't produce a photon. It just produces part of the field that becomes a photon.
That were given out in all directions by luminous objects. According to Newton, the reflection of light was similar to the reflection of a ball thrown at a hard surface. The ball bounces back at the same angle that it was thrown at.
So again, this is a little more complicated, but it's energy in, energy out equation. So you could argue that what's really happening is a U-turn, right? Something goes in, and what it's really doing is that it's doing the reciprocal of the circle. The energy in isn't enough to keep it in this, to have it absorbed. So it's released again, and so that would equal angle in, angle out. Now the same is true as if the energy is hitting, say, for example, a proton, and it's going to be leaving perpendicular to how it went in, because of the rules. That would also explain it. Anyway, but leave us continue.
If we consider the initial velocity of the light particle at some angle I, then we can resolve the velocity into its horizontal and vertical components.
Right, but that doesn't... See, comparing it to a golf ball or a tennis ball or some kind of physical ball doesn't explain why balls reflect. Right? Because the ball does hit the surface, compress, and then release the energy in the forward direction. So that's all a complex process of actions and reactions. It's not like it's a law. It's a rule of behavior. It's a rule of a cause and effect interaction, a sequence of events. There's no one event that makes the ball bounce off the surface. There's a whole bunch of events that make the ball bounce off the surface. And the same is true for the piece of force hitting the surface. What's going to decide whether it reflects or is absorbed is a sequence of events.
As the ball hits the surface, its vertical component of velocity is reversed, but the horizontal component remains unchanged. So we see that v sine I equals v sine r, and therefore sine I equals sine r, and so we see that I equals r. The angle of incidence equals the angle of reflection, and the light particle is reflected at the same angle at which it hit the surface, which we recognise as the famous empirical law of reflection.
What you're really just saying is that in one direction the energy is U-turned, and in the other direction it's left alone. So, that's another way of saying it. The reflection can be just as simple as a reflection, that one thing hits and then another cue ball hits from the other side. The reaction is just dependent on whether there's a force to meet the force, a counter force. If there's a counter force, there's a reflection. If there's no counter force, there's an absorption.
In order to explain refraction, which is the bending of light as it passes from one transparent material into another, Newton is...
So Newton's explanation isn't an atomic explanation. So he doesn't know anything about the fact that the thing is all magnetic or electrical, and all these atoms are bound together, and electrons are what's really conveying the energy. The electrons moving are what's moving the photons from one place to another. The reason why it's transparent isn't because the photon is going through empty space. And we already know this is true because we know that the light takes time to get through the glass. I mean, Newton didn't know all this crap. We had some, lenses were, you could speculate on path lengths, and that the path lengths were different in the different parts of the lens, and that was the fact that you're creating a time differential, which means you're creating a phase differential. So all that stuff he knew something of, but he didn't know enough of it to be able to put it all together.
Assumed that there was a force.
But I mean, it was 300 years ago. So, and what advance have we made in those 300 years except to wooify and religionize some kind of simple model? So we've taken the very simple model and just made it complicated and confusing and wooey.
Attraction between matter and light. According to Newton, when light particles were in the middle of a transparent medium such as air, glass or water, then the forces acting on the particles acted on all sides equally, and therefore there was no resultant force.
Right. So, but he can't, like I said, he didn't know that the substance is really just a matrix, and that because the atoms are bound to each other, there's explicit geometry in transparent objects. And so that geometry is what's allowing the energy to travel in straight lines through. So once it gets through the surface does the change in direction. Passing through the substance is very straight, and then again you're leaving the surface, and the surface is again what changes the direction. So the math is done on the surface. The surfaces are causing the effect.
However, if a beam of light is aimed at a glass block, then at the boundary between the air and the glass, the forces are unbalanced, and there will be a greater force of attraction on the particle towards the glass. This means that the horizontal component of velocity increases, whereas the vertical component remains unchanged.
So this, again, is not really Newton. Newton basically speculated that the light actually moves faster in the substance, that it speeds up, okay, which was clearly wrong.
The increase in the horizontal component explains why the light ray changes direction towards the normal on entering the medium. It can also explain the increase in the angle of the light when leaving the medium.
So again, there's no explanation. There's just telling us the geometry and saying the geometry somehow explains why it happens, and it doesn't explain why there's a rule. So saying, hey, here's the rule. Well, the rule doesn't do you much good if you don't know why the rule is causing the effect. So if you don't understand the cause of the effect, that's the part you want to understand. You don't want to call the cause, well, it's that, sine theta rule. No, that's not a frickin' explanation.
However, Newton's particle theory was not without its problems. Firstly, Newton's theory required the speed of light to be faster inside a medium than in the air.
Right, so that was the part you should have gotten to. And it didn't require. It was just the model he used relied on that being the pulling force. So it was speed that was the pulling force. That's why the light was being bent, is because it was speeding up. Right? So, I mean, that's, so again, to say relied, it's just because, yes, his wrong model of why the light was attracted to going into the surface was this idea that the attraction would be a speeding up. Just as logically as you would think something's going to speed up if it falls into Earth's gravity, it speeds up. I mean, yes, there's a logical intuition there. And that's what Newton was relying on. But let's understand, Newton didn't understand any of the chemistry, really. Come on.
And this would later be shown to contradict experiment. Secondly, if luminous objects are continuously emitting particles of light, then Newton's theory predicted that the object should be constantly losing mass. And
okay, so again, that's not true, because we know that it's only producing light because you shot electricity into it, or you shot something into it, right? We know nothing produces light, and things like the sun do lose mass. So we do know that the things producing light are actually losing mass. Things that are reflecting light, well, obviously they're not losing mass because they're not producing the light. They're just reflecting the energy. So we know that it's energy in, energy out. So there was nothing wrong with that part of Newton's statement. So to say that somehow we know differently now, no, we know exactly that to be true. And Newton didn't, I don't think Newton made predictions about what is creating light and what doesn't create light. I think Newton knew perfectly well that when a surface is reflecting light, it doesn't have to lose any mass. Reflecting light doesn't make you lose mass.
Finally, Newton's theory struggled to explain what happens when light passes through a narrow slit and spreads out.
Okay, so some more bullshit, right? When Newton was the guy who discovered the effect, okay, and he didn't have an explanation for it, just like you don't. I mean, come on, you haven't improved on Newton's theory, okay? Newton didn't posit a theory, so to speak. He didn't, he could have made one up about, I'm pretty damn sure that Newton said, hey, the surfaces seem to have something to do with it, okay? I can't say for sure he said that, but I'm pretty damn sure that's what Newton said, that surfaces seem to screw light up. It's quite obviously the variable. Why does the aperture make the light do this? Well, because as I make the aperture smaller and smaller, there's a higher and higher likelihood that the stuff going through the opening is going to be really close to a surface. And the bigger I make it, and all of a sudden all those effects disappear, it's because there's less likelihood that the force went anywhere near the surface. I have a huge volume I can pass through now. I don't have to hit the surface. I don't have to be anywhere near the surface. So obviously the surface is causing the effect. This is just too stupid. You people still believe this Feynman crap that, Feynman's telling you that it doesn't matter whether the photon goes here. It doesn't matter whether it goes right here next to the surface. Those two photons will do the same exact thing randomly. They have the same probability of being diffracted. The one that goes right next to the surface, same probability as the one that goes right through the center. You people are stupid enough to think that's logical? You don't understand the surface is everything about the experiment. It's the complete experiment is the surface experiment. The surfaces are the experiment. They are the phenomenon. Just think about it. Do you really think that that's true? That Feynman's right? That somehow it doesn't matter whether the photon goes right here or it goes right through the center. Same thing happens. It's randomized. The random God says, you must be randomized. You think that's the truth. You think that's a good theory. Shit. Shit. Alright. So that's probably a good enough place to end. Maybe we'll come back to this. So we got to 5:30. So, because you can just go on and on. I could just keep pointing out how, see, why did you fall for this? Why did they fall for this? Can't you people be rational and fair and say, yes, these people were ignorant. They didn't know everything we know. We can do a lot better than them now. And we can take all of this wooey God crap out of the physics and just deal with the physical phenomena and say what's causing the effect and what's a reasonable model of a cause. And it's not reasonable to say it doesn't matter whether it goes through here or goes right next to the surface. Same thing. That's not reasonable speculation. There's no reason for you to think that there isn't an explicit relationship between the surface and the event. It's so obviously true. It's so sensible, reasonable, and you don't have a single logical argument to make that there's any evidence that the surfaces aren't causing the effect. There's absolutely no evidence that the surfaces aren't causing the effect. In hindsight, whenever the day is that they decide you assholes, you sheeples, get herded in the right direction. Somebody's able to play the right tune on their little flute and you all point in the right direction for a change. This video is going to be dug up and somebody's going to say, shit, he was telling you this. It was so obvious. And you just sat there doing your, I fart in your direction and just following your some other stupid flute sounds. You're just so damn stupid. I mean, this isn't hard to know that their physics sucks. The evidence sucks. The theories are just wooey nonsense. And you all, you're attracted to it. You have an obvious compulsion, to give me a silly story because, reality's boring. Anyway. I hate this planet. It's just so fucking dumb. So, anyway, this has been a DraftScience video presentation. Till the next time and such.